Hi guys, so today we're going to go over a couple of different things. First thing we're going to go over is some like actuarial notation on lifetime. So we have TPX is the probability that someone who is aged X will survive T more years, T more years, and then TQX is probability that someone aged X will die within the next T years, And so obviously these two should add up to one, or the probability that someone will die in the next T years is one minus the probability someone will survive at least T years. So these two are complements. And then there's different relationships that you should know regarding this. So, like for the probability that someone aged 30 survives another 2 years, that someone aged 30 survives 2 years, is the probability that someone aged 30 survives 1 year times the probability that someone aged 31 survives another year. This is a relationship that's very important for us to remember if we want to go into like customer segmentation. So customer segmentation is all about categorizing different customers based off of their demographics, their attributes, their characteristics. So you can use many different clustering algorithms, k-means, k-modes, dbScan, hierarchical clustering to group these different customers or consumers into different segments. And so segment one may have customer with certain attributes, whether it's preferences, demographics, etc., depending on the data set they have. And so when you have like four or five, or depending on the business problem, number of customers, what you can do if in customer segmentation is tailor the marketing strategy for each different segment. So every single segment will have its own catered and tailored marketing strategy depending on the needs of the consumers, the characteristics, the preferences of the consumers. So the marketing strategy will be different for each of these different consumers, as well as the product distribution will be different. You can imagine that for certain consumers, they have a certain preference, they have a certain demographic information, whether it's location or income, they are going to have a higher need and want for a certain type of product more than others. So you want to make sure that the distribution of the products as well as the marketing campaigns are aligned with the segment themselves. So that's the pivotal concept in customer segmentation. If we're looking at, and then there's many different clustering algorithms that you can use. So if we're looking at k-means, like we went over k-means, it's obviously uh, based upon the number of clusters. So you first have to give it k number of clusters. It works on only on numerical data. It's able to find centroids of the clusters. So first it's going to randomly initialize the centroids. Then it's going to find the data points that are closest to each centroid. Then it's going to recalculate the centroid based off of the new data points that are assigned to each centroid. And then finally, when you get to a point where where two consecutive iterations of this occurs and you don't have different clusterings, you have the same clustering, then k-means is ended. And so that's k-means. We also have hierarchical clustering where each cluster is first, or each data point or observation is first its own cluster, and then we're calculating the dissimilarity between those data points or those clusters, and then the ones that are most dissimilar get merged first, and then the ones that are least dissimilar get merged later. And so we were able to get a hierarchical or nested clustering relationship between these data points. And then we also have dbScan. dbScan, what it does is it clusters based off of density. So you can have like, let's say we can have like a data set that looks something like this, where all these points are pretty dense, really like very, very close to each other in like this particular shape. And then you could also see like these points are also very densely close to each other. So you can see like these are the points here. And now what dbScan is going to do is dbScan is going to group the densely populated points together. So what it's going to do is it's going to group this densely populated group. It's going to group this densely populated group. This is different than k-means because k-means relies on Euclidean distance. So it's possible like for k-means, obviously this is and this point is probably close, right? So it's possible that in k-means or in k-means, these 2 points are probably going to be within the same cluster. But in dbScan, because we're clustering based off of the how densely populated each group is, we're going to get a different clustering result. So depending on the use case, depending on how you think your clusters are, the shape of your clusters, you're going to want to use different clustering algorithms. Now let's talk about data imbalance. So data imbalance is a very critical issue in machine learning where you have the majority data significantly 90-10 or 95-5, 98-2 significantly outweighs the minority class in terms of the distribution of the data points. So you can have a variable, you can have, let's say we're looking at customer churn, and there's only 2% of the customers that have churned, and then 98% of the customers have not churned. So this is a data imbalance problem, and it can lead, if you're using accuracy or if you're using accuracy as a metric, your accuracy might be really good, but that's because you could just label everyone as not churn, and that's going to give you like 98% accuracy. That doesn't mean that the model is actually performing good. So in those cases, you really have to look at like precision recall, true positive, false negative, things like that. So how can we get rid of this data imbalance problem? How can you balance the data? Well, there's many different approaches. First approach is by oversampling the minority class, undersampling the majority class. So oversampling the minority class means you're creating duplicate records of the minority class. So if our minority class is churned, we're essentially creating, and let's say we have 200 churn, and then we have, or I guess let's say we have two churned, two customers that have churned, 98 customers that have not churned out of a total of 100. We're essentially creating duplicates of two until we get to this 98, until our classes are balanced. So that's oversampling, oversampling the minority class. We can also undersample the majority class. So we could take two from this not churned, and we can have two and two, and that's a equal cost, equal balance. That's a balance between the two categories. And so there's many different ways you can balance the data. Again, this depends on the business context, the data that you have, the number of counts that you have within each, what the ideal scenario is, what you're using this model for. All that depends on which data imbalancing technique you want to use. There's also SMOTE, which is a popular framework or which is a popular technique to use to help solve this imbalance. And what SMOTE does, as opposed to oversampling and undersampling, which essentially creates replicates or duplicates of the observation, what SMOTE does is it creates new synthetic data points. And so you have, let's say, churn data points. Let's say you have two data points here. What SMOTE is going to do is going to create new data points that are closely related in terms of like the neighbors. They have this entire algorithm that's being used there, but they're going to create extremely close new synthetic data points that are close to the churned observations. So we're going to have new observations that essentially mirror or nearest neighbors to the churned data points. And so what this does is instead of having the same data points in our model, maybe in our model, that's redundant. We're creating new data points that are based off of the distance and the nearest neighbor to these to the minority class. And so we're able to create new synthetic data points with SMOTE, and it's very commonly applied and used in practice. We're going to go over LeetCode problems. So two-sum is a very popular LeetCode problem. So what you have to do is you're given an array of numbers. So 6 to 8, 6 to 8, 10, 15. And your goal is to find the two indices that get you to the target number of, in this case, let's say it's 18. And say it's 18. So in this case, it would be 8 and 10, or it would be 2 and 3. You would return 2 and 3. Now, the brute force approach would be to obviously go through all of these data points, and then for each data point, still go through all of these data points. And that would be an O of n squared algorithm. So you can go with for each data point, you can go over for each data point remaining, right? For each data point remaining in the list. You can simply add them and then check if it's equal to the target. If it is equal to the target, then you can just return the indices. This is an O of n squared algorithm. But there obviously is a much, much faster way to do this through hash maps. So what you can do, so in this example here, what you can do is our fundamental question that we want to answer is how can we get these two indices that get us to our target value? That's the question we want to answer. So what we can do here is, let's say we want 18, right? Let's say we want to get, our target is 18. Every time we go through an element in the list, we ask, have we seen its complement before? So have we seen, this is target, have we seen target minus number before, right? So if we're at 6, have we seen 18 minus 6, the complement? 18 minus 6, have we seen 12 before? No. We go to 2, have we seen 16 before? No. We go to 8, have we seen 10 before? No. If we go to 10, have we seen 8 before? We have seen an 8 before. And so that's how we were able to solve this problem. And so we want a data structure that's able to store the indices of our previously visited elements. And we can do that through a hash map. And so this hash map is going to contain the values that we have already seen mapped to their respective indices. And so the code is going to be, we're going to go through, we're going to iterate through the list, right? We're going to we're going to create a map. We're going to create a hash map. And again, this hash map is going to contain the visited items or the seen items in this list. And so we're going to loop through basically the list. We're going to loop through the list, and then we're going to get the complement, right? So the complement is going to be the target minus the current number that we're at. And then if we see the complement in the map, okay, if we see the complement already in the map, then we just return the index that it's referring to. So if we see the complement in the map, then we just return our current index that we're at, and then we return the value. We have the key. We can return the value that the key is associated with. So we're able to do that, and then we could and then we can just add. We can just to populate the map initially, right? We could just add in the. We can add in our. We can populate our map. So we would just do map number equals I. So we're associating the number with the index. So this will just be the index. And so the requirement for this is there will always be two numbers that will add up to the target. So we don't need to worry about if the case what would be the case be if they don't equal to the target. We've gone through all of our options. So let's go through, and this is obviously an OVENS linear time solution. Now let's go through how we were able to come up, like the thought process behind coming up with this algorithm. Because brute force, it's O(n) squared. How did we, how were we able to get to this? What are some of the thought patterns and patterns that we recognize here? So the first thing is you want to have a different perspective on the problem. So by different perspective, I mean you want to view the problem in a different way. So the problem statement is we need to find two indices. We need to find two indices such that their values add up to the target, right? That's the problem. Now, how can we look at the problem in a different way? Instead of adding two indices, instead of finding two indices that add to the target, we need to find a value and its complement, right? Instead of finding two numbers that add up to the target, that's one way to look at it. Another way to look at it is we need to find the value and the complement, right, to the target. If we see that in the list, return those in. If we see that, return the indices of those two, the number and the complement of the target, right? So instead of num1 and num2, what we want is we want num1 and we want target minus num1, right? Instead of num1 and num2 such that num1 plus num2 equal target, we want to get num1 and target minus num1. And how can we store this target minus num1? We can use a data structure. So the first step is really thinking about the problem in a different way, breaking down the problem. Can we solve this problem? Can we have a new paradigm, new perspective shift on the problem? Yeah, it's asking one thing, but can I make it that it's asking something a bit more easier to actually solve? So that's, you want to have a different perspective. The second thing is always just having like a brute force method in mind. Like always just going down and writing out what's the brute force method. It's going to help you gain a lot of clarity in the beginning first on how to actually solve the problem, and it will help you understand the problem as well. So we always want to do a brute force method first initially, like think of it. Third is can we use a data structure? So in this case, we used a hash map. Can we use a stack? Can we use a graph to help solve this problem? Can we use some sort of data structure that's going to help us solve this question? And then we want to really break down the problem. Is this a similar problem to what I've seen before? Can I break this problem down? Can I simplify the problem, break it down uh, into different steps that I know how to do? Is this problem something I've seen in the past? You want to break down the problem. So having a different perspective, paradigm shift on, can you phrase the problem differently? Can you reword the problem to, can you essentially do the same problem, but in a different way? Can you think of a different way to do the problem? And that's going to probably help you get a more optimal solution. So that's the first step. Second step is think of the brute force algorithm. Third step, can we use a data structure? Fourth, break down the problem, simplify it, and really get an idea of what the problem is asking. Are there any patterns that you can use? Understanding your assumptions, that's going to help you solve these different problems. So even just from this one LeetCode question, very basic LeetCode, two sum, LeetCode easy, you can actually learn a lot of different fundamental concepts of problem solving that you can apply to other programming questions and LeetCode questions. So that's it. Hope you enjoyed the video, and I'll see you in the next one.